Good afternoon, all of my dear students. So today started with the first module of our utilization chapter. Okay. So first module, we know that that is focused on the electrical tractions. Okay. So today I am going to discuss about the electric traction system. Okay, so what do you mean by the traction? How we are implementing? How we are implementing? Okay, in the practical cases. Okay, what will be? How it will really look like? Okay, so that we will discuss here. Okay, so in this chapter. Okay, so before starting any chapter, we must know about the basic motivations of the chapter, means why it is known about, why it is known as, means why the chapter is important. Okay, so definitely we need to know about the what, why and how. Okay, so what, why and how we are going to implement them, that is that we are going to discuss over here. Okay, so what is the motivations of the traction? Normally, you know the different applications of our of the traction system. Okay, that normally applied in our locomotives. That is number one applications, means railway systems. Okay, then harvest. Okay, harvest, then crane. Okay, different applications of their instruction. Okay, means huge force, means in single word, means small, means very, very low speed, high torque are required. Okay, in that case, the traction is much more important. Okay, so today I'm going to discuss about some electric traction system for Indian Rail. Okay, not like Indian Rail, means railway. Okay, so that here we can see that that slide consists of the locomotives. Okay, what type of locomotive is it? That one. It's not the electric locomotives. Okay, basically that there is no electric contacts over here, so there is no overhead wire. Okay, so it is not the example of electrical locomotives. Okay, so that is a goods carrier, so there is a range. Okay, different model numbers are there. In my next slide I will discuss over it. So range are there. Okay, so that the normally most important thing, the traction, where the traction motors are situated. So that wheels. Okay, now you are able to see the wheels. That wheels are there from front side as well as some back side. Okay, so that wheels means that wheels are joints. Okay, by the pinion gear joints. Okay, the tractions motor normally connected with these wheels by the pinion gear junctions. Okay, so pinion gears are there. Okay, so that you can connect with them, and the motor is rotating. If the motor is rotating, that is responsible for rotation of the shaft of the motor, and shaft is directly connected with the wheel. Okay, if the shaft is rotating, so definitely wheels are also been rotating. Okay, and that will be responsible for motions of that locomotive. Okay, that is that we can observe over here. So if it is electrical tractions, means if it is there is no electricity, so in that case how that motor will be work. So initially the initial days there was no direct electrical motor. Okay, there was some piston. So in the steam engine, that steam engine is responsible for the movement or the rotate, means shaft movement. Okay, that shaft piston is directly connected with that the wheels. Okay, so if the shaft means stroke. Okay, the movement of the 2T means initially it was two-stroke engine. Okay, after that it will be four-stroke, then six-stroke. Okay, like that way. Okay, so for two-stroke engine, so the efficiency of the different stroke engine and their comparison. Okay, so that strokes are responsible for movement of that wheels of that locomotives. Okay, so if it is steam, so steams are responsible for movement of the shaft. Then the diesel has come. Okay, then the combustion was there. Okay, due to the combustion, if it is enough oil enough to means combustions are there, means IC engine, you know, no, the internal combustion engine. If it is oil enough to drive that strokes for that wheel, so then we can use the diesel. After that, what happened? Right now, two locomotives are there. Two types of locomotives are there. That is directly electrical locomotives. Means from the overhead, that locomotive is directly collecting the current. Okay, from the overhead, and that current is responsible for driving of that electrical motor inside of that. Inside means below side, means that motor will be situated here, just back side of your wheels. Okay, there are two sets of wheels. No? In this size you can see three wheels, and back side another three wheels. Okay, total six wheels are there. So two wheels in their single shaft. Okay, three wheels are there. So three shafts will be there, and normally one motor is responsible for rotations of the two wheel. Okay, so you know that three motors are there. Okay, one, two, three wheel set means six wheels are there. Six. So three motors are responsible for movement of the six wheels. Okay, so front side three motor, back side another three motors are there. Okay, for the mechanical energy means for the diesel, so that from the diesel it will generate the electricity, and that electricity drive that motor. But the electrical loco directly taking that electricity from the overhead line, and that electrical energy is responsible for that electrical energy is responsible for movement. Okay, that responsible for driving the motor set. Okay, so that's the basic operations. Okay, that's the basic idea you can get here, and in that way that you know that motors are and the machines are rotating. I mean, tractions motors are driving to the entire locomotive. So you know the basic history. So before starting anything, we need to know about the history. So it is your Himalayan railways. Okay, so that is very old railways. Okay, so Himalayan railways means that you know that known as the toy train. Okay, so that is in your Darjeeling. Okay, Darjeeling means it was started in 1950s, means British India at that, just after the British India, and I think it was started in steam until mid of 1950. Means you say like that it is before that 1950s. Right now that also the steam engines, I don't know the steam engines is there or not, because I'm not able to go there right now. Okay, so I didn't see that one, but I heard that initially it was the steam engine. Okay, so that steam engine means it was started by the Himalayan railways, means started by the British government. Okay, that toy train means, how do you know that one? So gauge. Okay, so gauging means meter gauge, means broad gauge, narrow gauge. Okay, so what type of gauge they are using? So right now in Indian railway, so narrow gauge lines are totally obsoleted. So some of the lines were there, but 3 4 years back, okay, that was totally stopped. Okay, that was totally stopped. One line was then in Maharashtra. Okay, so that was stopped on there in West Bengal. That was also stopped. Okay, other places may be there, but I don't have such information. So, okay, that I read out from from newspaper. That's telling you. Okay, so that narrow gauge are not there. Okay, right now all are in the broad gauge line. Broad gauge line means, why that gaugings are important? Basically, that gaugings means the difference between two wheel. Okay, so if the train wheels length, gauging means two wheel this distance will be less. Okay, so special type of, if all the railways are not in the same specifications, if the specification wheel specifications are different. Okay, so if the specification is different means what? That load carrying capability of the wheels also be different. Only not like only the length of the wheel. It also talking about the diameter of the wheel. Okay, diameter or single word you say like that, the radius of the wheel also be different. The special type of wheel you need to be designed. So that's why they are make it obsoleted. Okay. So basically on the demand of that public, so day by day that load demand is increasing, means load demand means the demanding for the rating of the locomotives day by day it is increasing. So that's why that narrow gauge are totally obsolete, but still it was in a heritage. Okay, so here you can see some steam engine. Okay, some steam engine, both of the cases that steam engines are there. Okay, that was responsible for movement. Okay, that was responsible for movement of the railways for early 50s. Okay, mid of the 50s. Then here you know the types of locomotives. So initially it was steam. Now you can see it is your now you can see there it is your not steam engine. It is diesel based. Okay, especially diesel based, and it is electrical locomotives. Okay, so you know that EMU look like that. Multiple units are there. Okay, so both of the cases you can see. So in the traction system, what we need to know is classifications. Okay, what are the classifications of the traction system and the nomenclature. Okay, classifications and the nomenclature. Next one is the power supply in the electrical traction. So what type of power supply we need to use for the electrical traction, that is important. Okay, so if it is AC power supply or the DC power supply, if it is AC, so what will be the advantages for using the AC power supply? If it is DC, so what will be the advantages and the disadvantages? So all the cases, advantages and disadvantages both are important, and based on that you are going to design the power supply. Okay, then what type of traction motors we are normally using? Okay, the rating of the traction motor, then different size and different sorry rating of the traction motor, different types of the traction motor. Okay, if it is DC series motor or it is different with the DC series motor, means you know that initially it was DC series motor, then right now for the big motor drive, means large motor drives for the locomotives. Okay, so normally induction drives you are using. Some for the not like tractions, means it not like only the railway systems. Okay, it also related to our city ride also, and so it is four wheeler, three wheeler, two wheeler, whatever may be the wheel size and their shapes. Okay, so what type of motors are using? So in that case we are also using some special type of motor, like you know that in robotics the wheels are controlled by the stepper motor. Okay, so by the giving the inputs of the stepper motor, so stepwise means stepwise it is changing its position. So okay, so very sophisticated control was there. Then in case of two wheeler, okay, means two wheeler electric bike. Okay, in your big in your city for your city ride. Okay, so two wheeler electric bike or two wheeler cycle, means bicycle, but it is battery driven cycle. Okay, or the golf cart. Okay, so all the cases you know that special type of motor means you are using BLDC motor. Okay, but these type of motors like stepper motor, BLDC motor, all are in very costly motor, and they are not capable enough to drive the electric train. Okay, so in that case you have to find out some specifications of the motor which is are in very robust in nature and more or less less costly. Okay, or they are less costly. Okay, so in that case you can observe that induction motor is better to use. Why? In compare with the DC motor. So in case of DC motor, the problem is that so DC motor, if you see the DC motor, the sizing of the motor. Okay, the sizing of the motor is quite big in DC motor, but same rating, same rating of induction motor, the size that they are in comparatively lesser in weight. Okay, so some specific differences are there. Okay, so in the DC motor, what happened? It's a conduction motor. Okay, so due to there is a conduction motor, so the brasses are there, carbons are there, so a lot of noise are there. Sometimes noise, flashing, then dust particles. So you have to all the time regularly. There is a armature, there is a commutator segments in the DC motor. So all the time you have to make them clean. Okay, make them clean. Means commutator segment is not clean, then what will be the problem? Then you know that two of the commutator there is some mica, there is some grooving and there is a mica, given the mica insulations. If that part is hot circuited due to the dust particle, if the carbons are there, okay, carbon deposition is there, then these two commutator segment may be chances for the short circuited. If there is a short circuited, then what happen? Then automatically initially it's a big size of motor. Okay, initially there will be no problem, but after certain time, if that is repeatedly doing that short circuiting and repeatedly all the commutator shorted, then there will be the problem of the damaging of that machine. Okay, so all the time the maintenance cost, okay, the maintenance cost of the DC machine quite high compared to your induction motor. Okay, these all are the different pros and cons. Okay, so why we are considering the induction, switch to the induction motor drive. Also the controlling aspects. Okay, induction drive, the vector control, scalar control, both of the controls are possible. Okay, so that's the basic motivations for the selections of the traction motor. Okay, so now the control of the traction motor, that I am telling you as per your motor specifications and the rating. Okay, and the load. Okay, so rating of the loads. Okay, you have to design that motor. Okay, so you have to design the control of the, you have to design the control of the motor. What type of control you need to do. Okay, so that I am telling you. So is it vector control or scalar control? Okay, if it is not, which or whatever maybe your logics are there. Okay, if it is microprocessor based control, microcontroller based control, so what type of controller you are using? So totally depends upon your control structures. And finally the braking. Okay, so if the braking is there, so which type of braking you are giving the most emphasis. Okay, so if you can take one example like your suburban, okay, sorry, so like your urban transportations. Okay, urban transportation means city, one city to another city. You know that electric locomotive, EMU, electric multiple unit. Okay, electric multiple unit means those are going to Mumbai or the Calcutta. So okay, so they can see some of the not mail train, the lot of from the metro city you can see, and Delhi also sometimes. Okay, so in metro city, so a lot of people they are trying to reach the city from the 100 to 150 kilometers, sometimes 150, but normally 50 to 100 kilometer away from the metropolitan city they are staying there. Okay, so every day they are try to avail that local trains. Okay, that is also known as local trains, means EMU, electric multiple units. Okay, the structures, okay, the structure, load carrying capability, and the machines point of view. Okay, and the different machines point of view, that EMU are quite different. Okay, quite different with your means normal good carriers locomotives and the mail trains locomotives. Okay, but another thing is also be there, that is called memo. Okay, memo means it's look like a intercity. Okay, like your two city. Okay, in you can say like that, that range of memo, that EMU normally travel every day between two city, like the distance between two city is 100 to 120 kilometer. Okay, more than that it is not, means not going, that EMU. But MEMU can go up to, you can say like that, up to 150 kilometer or more than 150 kilometer, like 200 kilometer. Okay, the range of the EMU is 100 kilometer, but the range of the MEMU is more than 100 kilometer. Okay, means it is near a minimum 150 kilometer, maybe maximum 200 kilometer, like that. Okay, basically as per their applications, as per their operations, their braking system also different. Okay, in EMU system, when those are using for the normal intercity, not intercity, means normal city riding, like that, urban transportation. Okay, urban transportations. In that case, if you using that EMU, you know that there is a multiple times you have to break that train. Means the distance between two station is maximum. You know that 5 kilometers. Okay, sometimes it is maximum 10 kilometer, but normally it is 5 kilometer. Okay, minimum 5 kilometer, maximum 10 kilometer. Okay, so all the time what happened? Train need to be pick up and reach to the base speed, then suddenly it need to brake. Okay, so that in that case dynamic braking is most important. Okay, so in that case they need to go for the dynamic braking. So as per the braking, as per the route of the trains, okay, route of the train, the braking topology also been different. Okay, but in case of memo, in that case you know that in between two station is minimum 20 kilometer. Okay, in that case, so then what will be the problem of the dynamic braking? The main problem of the dynamic, the huge energy has lost. Okay, so you need to utilize that energy. Okay, you need not lost that energy. So that's why for the dynamic braking, so it is not cost efficient. So the memo, those are traveling for 200 kilometers, but the station between two station is minimum 10 to minimum 15 to 20 kilometer, then what happened? So they have the scope for regenerative braking, then dynamic braking is important. Okay, but after doing 60% before reaching the station. Okay, so before reaching the station, so after some period of the traveling of the machines in the memo, they go for the regenerative braking. What is regenerative braking? Means their actually motor behaves like a generator. Okay, so that's why it is called regenerative braking. Means motor feedback or motor send back the additional energy to the wire, means to the connecting wire, means to the catenary and the dropper that was then in the overhead wire. So force back to the additional energy to the overhead wire. So it having some limitations. Okay, so if regenerative braking is there, so there in the line there must be some other sources. Sorry, there in that line there must be present some other loads that can take additional power. Okay, so you know that in the same line lot of locomotives are there, lot of train or locomotives are there. If the regenerative braking is there, that additional power will be taken by any other train that is in the loop, that is in the line. Okay, that also taken by their side. Okay, so that also been possible. I think all of you getting my point. So in local EMU, so when it's local train, that regenerative braking is not possible. Only dynamic braking, and the dynamic braking causes a lot of energy loss. So for the memo system, for the memo train, so we can go for the regenerative braking, then we can go do for dynamic braking. So how much percentage you have to run up to regenerative braking, then the dynamic braking, that you need to calculate. As it depends upon the machine rating and the distance between the station and the and your locomotive. Okay, so braking is another important issue. So which type of braking is important, for the regenerative braking or for the dynamic braking? Which one is important that you should to consider? Then in traction, you know that the traction, the locomotions on the rail, driving force, then steam or the electric drive. So traction is related to your driving force. So which type of driving force you are providing there? Okay, you are providing there, and if the driving force is there, then which type of motor you are going to be used. That's why it is written that classifications, or the driving force is relevant which type of energy. Okay, is it fossil fuel energy, means is it diesel, or is it electric, okay, or is it any other thing, that you need to specify. Okay, classification of the traction system, non-electric traction and the electric traction. Okay, so non-electric traction means you can understand that steam engine. Okay, sometimes the initial is the diesel engine. Okay, that combustion, so there is no generation of the electricity. Okay, that directly that wheels are moving by the generated energy from the steam or the diesel directly, like combustion engine means it provides the stroke. Another one is your electric traction, okay, that receive electricity externally. So there is a overhead line, okay, that motor directly take that power from the overhead line, okay, directly take the electricity. And self-contained locomotive, so sometimes those are in the diesel engine, so they can do their own generation, okay, they can do their own generation, okay. So if the diesel is there, the combustion of the diesel will be there, and after combustion of the diesel, automatically electricity will be produced. That electricity you can use for the motor, that electricity you can use for the traction motor, okay, that is self-contained locomotive, okay. So two things are important, non-electric traction, another one is the electric traction, okay. So that is important. After that we can go for that nomenclature of the Indian railways, okay. So that I'm telling you, so what are the important specifications, or what are the important things we are using in our system, okay, in our Indian system. So name consists of the four parts, okay. So what are the four parts, you know that one, you know some examples like that, that written in the machine, that beside of the locomotives, na WDP2, that is written like that. If you follow it when you are traveling by the mail train, you can follow there, okay. So you can follow there what model number is written there, skin their side, okay, or the in front of the machine means locomotive. So if it is written WDP2 means it is a diesel electric passenger, P for passenger, okay. This is diesel electric passenger train running on broad gauge, okay, running on broad gauge. So there is some specifications, okay. How do you understand? So gauge you can understand from WYZ, okay, W or Y or Z, okay. W stands for your broad gauge. So here you know that W is what it is, BG means broad gauge, okay. B for broad, G for gauge, Y means medium gauge, okay, and Z is your narrow gauge. If in this place ZDP2 is there, then you can say like that, ZDP2 means diesel electric passenger train, P for passenger actually, okay, P for passenger train on narrow gauge. If it is Y, so it will be, in that case it will be medium gauge, okay. So like that way. So then A and D, what do you mean by that A and D, that D and A it is written na? So WYZ it is stands for a gauge or the type. Then A and D is the mode of traction, okay. So A and D means it is mode of traction. A means AC traction, okay. A means AC traction, it is written D. D means diesel traction, okay. Diesel traction or not DC traction, okay. It is diesel traction, okay. And here you know that one, P for another specification is there, what for it is used. P for your passenger, okay. G for the goods, M for the mixed passenger and goods, and S is shunting, okay. Then another thing is the model number, okay. Model number is there, number of you know that model number 2, okay. So model number 2, 4, 6, 2C, okay. So number of traction motor, you can say like the model number or the number of traction motor, okay. So how much more number is there? 2 means 2 traction motor will be there, 4 means 4 traction motor, 6 means 6 traction motor, okay. It's look like that. So you know that length of the gauge, okay, type of gauge, okay, it is your type of gauge and gauge width, okay. So if it is your broad gauge means BG, so gauge width is 1.676, okay. If it is meter gauge, okay, if it is meter gauge MG, so it will be 1 meter, okay, or the moderate gauge, okay, by medium gauge, okay. Meter gauge or the medium, it is 1 meter, that's why it is written. Now meter gauge means 1 meter, okay. NG means is a narrow gauge, below of your 1 meter, it is 0.76 meter. Another one is LG. LG means is your light gauge, so it is your 0.610, Okay, types of railway service. Okay, what are the normally defined types of railway service? Okay, that is your mainline service. You know that one, mainline service. Then city service or the urban service and suburban service. So mainline service means mail express. Okay, so it is coming. It is traveling by the interstate. Okay, interstate. Okay, that is normally the mainline service. Then city service or the urban service. Urban service means in between two cities it is traveling. Okay, means maybe more than 200 kilometer. Okay, sometimes it is 300 kilometer. Then it is called that intercity. Okay, intercity express sometimes. Okay, or intercity memo. Okay, that is more famous for the city service or the urban service. Okay, another one is your suburban. Sorry, I just I told that wrong thing. Okay, city service and urban service means it is two city. Okay, it is two city means that city having the difference of 5 kilometer. Maybe town, you know, like that. Maybe in between two town. Okay, in between one city, one town. Their differences are there 5 kilometer. Okay, between two town or 10 kilometer. Another last one is a suburban. Suburban means it is suburban means it is you know that between one village to another city, like that way. So there is a station difference of the train maybe more than 10 kilometers or 15 kilometers. Okay, three types of railway service is available in Indian culture. Okay, in India, that the three types are there. Okay, types of gauges. Sorry, gauge of means gauge of track, that also given here. Okay, it is a standard gauge or the broad gauge. System on the tractions. Okay, systems of track electrifications. Okay, what are the most important things? So electrifications and the details, I think that portion I'll start with my next class. Okay, so basically it will take some more time. Okay, for the discussions of the electricity. Okay, so that what are the different types of wire, that I'll discuss in my next class. Normally we are in our tractions, electric tractions, we are using AC. Okay, so for the driving of the motor. So what are the specifications, or how that AC power is coming to your motor, the entire part, that I'll discuss in my next class. That will be better. Okay, so I will start it on the fresh class. So we give some more emphasis on it. Okay, so today I will discuss up to the types of gauge of different track and the railway service. What are the normal services available in our means Indian scenario. I think that is enough for today's session. Okay, so if you have any confusion, you can ask me. So in that case, I can repeat some of the portions. Okay, if you don't have any confusion, no problem. And if you have any confusion, you can write here. Okay, so in the chat box. So in that case, I can I can go through I can clear your confusion. Okay, if you don't have, no problem. If you have it, you can write it. Okay, I think you don't have any kinds of confusion. Okay, so today I can complete my session here. Okay, so just wait.